Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and this is It's On My Time. Today, I want to share with you an eBay purchase that I made several months back now. This has actually been sitting, I've been waiting for a chance to get some of the things done that I wanted to do on it. This is a stud welder, and down here I have the cables, the ground, and the stud gun itself. And they're disconnected from the machine right now because we're getting ready to pull the cover off, and we're going to be doing some modifications to this. This is about 1984, I believe, is what we figured by the information we found on the little circuit board that's in here. It is working. I purchased this stud welder online for $1,600, and that included the shipping coming here. When it showed up here, it was one of those things that you get and it's on a crate, and somebody stabbed it wrong with the pallet or whatever. And luckily, it didn't damage this unit here, but it did look pretty bad when it came in. So I don't know what it is with shipping, and it's not just trucking, it's UPS and once in a while FedEx, and United States Postal Service on priority mailing lately has sent me a couple actual cards that I got for another project that I'm going to be building my own CNC controller, and those boxes come smashed. So luckily it didn't look like they destroyed the components in that as well. So I've been blessed as far as not ruining what's been shipped, but my packages really have looked like they've gone through the ringer. Okay, back to our project here. This stud welder will weld studs up to 3/8 of an inch. Now, here's two samples, 1032 and a 1/4 inch stud that I have a box of each of these because I see these being used a lot. Now, why a stud welder? Well, my plasma cam gives me a lot of flat cutouts and stuff, and I see the future of being able to weld a thread off of the backside or off of a component that actually a box or some kind of fixture that I want to mount and have a threaded stud on it. I'll be able to put that on there without deforming the products. Okay, just like this mermaid right here. All right, we plan on doing some stainless steel mermaids, polishing them up and putting them on the mud flaps of a couple trucks here on the Cape, something like that. It's kind of in the line of idea why I sought for the stud welder. Stan Zinkowski and I were texting back and forth on Facebook, and we were looking at different sites, and he actually spotted this, and he has this exact model, and of course he's bought it a long time ago, and he said that he paid about the same price that I did for this, and it's given him many hours of use. So it kind of sold me on picking this thing up. And so when it came here, like everything that I pick up that's used, I want to open it up and inspect it, and so we did. Now, one of the problems that I noticed on this, and I strung out the leads and I did a few testing. When this welds a stud, it's capacitor welder, and those capacitors are charged up, and then the thing almost bounces up off the table when it's released. I'm exaggerating a little bit, but it does give a wallop, and so there's vibration and everything else. Now, they originally put this together with little sheet metal screws, and you can see that they were missing a couple. Somebody somebody exchanged threads with another style screw, and I want to remedy that problem. So I'm going to be redoing, let me put the cover down here out of the way. We're going to be redoing these holes. In fact, I've already put a couple in here along this edge here, and we're going to be installing nut rivets. All right, this is what a nut rivet looks like, and this is the other side. Okay, a nut rivet is installed with a tool, somewhat like a pop rivet gun. You drill the pilot hole, you insert that in, and then you crimp it or pull it. And I have these on this side here. We'll be doing in this top pieces here and here. All right, when we took this apart, John from Minnesota, my buddy, helped me inspect, told me how to test. We tested the capacitors, that they actually function, and that they bleed off. And I was in question about this resistor here that looks barbecued, and it's still functioning, but it does look pretty pretty spent, is probably the best term. Now you say, hey, how does somebody sell something like this? This machine is working. Okay, there was a few other things done, and it looks like a couple of the capacitors might have been changed out. And all right, there's a resistor on this board here that's also a little burnt, or it was hot at one time. It might have had to do with something that's happened to this in its past. All right, there was a new cord, there was a new ground cable, a new ground clamp. There was a couple new things that were on this when it was sold to me, and it in good faith, it was sold to me working. All right, and I'm only doing a couple things here to continue working fine and make some improvements. Okay, while John was helping me investigate this, he was also coming up with a couple things that would be nice to add to it. Okay, one, because these capacitors are made for bleeding off the excess current when the capacitors are dumped or the machine is shut off. You've got to dissipate that capacitor, and the resistors that's their function. So we picked up a fan, and we're going to be putting a fan in on this side of the cover, which will blow current across the transformer. There's a transformer in this section here. It'll blow across there, blow across the board, and then exit out the back. And I got I picked up a guard here so that nothing will accidentally get stuck in and make contact with the resistor or the power coming off of these leads here. Another thing that we're going to be putting in here, and this is going to be one of the first things, because I'm actually going to have to cut an opening in here. This is your desired voltage setting. Okay, and I'm going to put a meter in here which will read the actual voltage. So we got a meter in here, and we got to power that meter with low voltage, and we're going to pick up the AC side off of the transformer, and we'll also pick off of the transformer the AC to go ahead and run the fan. And we decided to go ahead and pick up a larger resistor, and we have leads here so we can stand it up off the board a little farther and get the air to pass by it and help keep it cooler. That's the intentions of this. And we also picked up a brand new resistor to replace this one back here. So we're just starting to get to this. We've had all these components for several months, and I have brand new 1024 screws to go ahead and be able to screw this back together. They did put a couple new rubber feet underneath here, although I had to tighten them up and adjust those. And we did a general clean out, and I also went around and made sure that everything is tight. All the contacts on that. These capacitors are all joined together my screws and making sure that they were 100% tight. So the very first thing we're going to do is we're going to take the little meter here, and I'm going to figure out exactly the square opening in here. I'm going to pull this dial off of here so that I have a little bit of room here. I can't just pull this whole front panel off of here because everything is a solder fit, and I won't be able to get all the components off of here to actually take it and say, okay, hey, let's mill that in there. Let's take it and plasma cut that in there. So I'm going to go ahead and take my little toy here. And they did give me a few bags of goodies to play around. And I think I got some mini discs there. And I think this might be something for the hobby job here. All right. So let's get it marked out and set up. Okay, let's see what this thing will do. I've got this covered. I was able to slide this protective blanket in behind the transformer and the backboard here, and there's no wires that we can hit into back here. And we're just gonna go ahead and we're gonna take this and we're gonna go ahead and see if we can get in here and grind this. Now let's see how well this little tool works. I think we're just gonna need a full speed here. Okay. I got a little groove in there. Let's see. That's disc 1. I wonder how many they gave me. Okay, I don't know. I might have about 20 of these discs here. I might actually be able to do this whole job with this. And this one here, I'm pretty well limited. You ever heard of zirconia or something? Something a little harder than this. Okay. We'll just slow it down just a little bit. I don't know if maybe I'm pushing it too hard or... Okay, I'm through in that one little spot. Okay, that's about 3/8 of an inch, 2 discs. So let's see, we got 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. All right, this is my 4th disc. Just worn a little bit, but it took a little over 3 discs to make that. I found that maybe 4.5 on the speed here might make a slight bit of difference, but it just might be that I was that close to getting that done. Okay, we're going to change out the wheels. All right, we won't torture you any more than we have to get the rest of this cut out. Okay, I think we got it. Yep. There we go. Okay, how close are we for our switch fitting in here? Okay, we're good side to side. We're just a little bit tight up and down, but that's cool because I can get in there with a real tool, one of my rotary burrs, and I can get in there a little bit with that, and then just come in and touch the corners there. Pretty good. And I only went out of the lines in that one spot there, but I do have some gold paint, and I can put a dab there just to make myself feel better. Excellent. Okay, that's going to fit in there nice, and we'll touch up that with a little gold there, just so that makes us feel better. All right, now we're not gonna wire this up here yet. This wire goes in here. We have black one's going to the ground of the capacitor. The white one's going to the positive side on the capacitor bank there, and the red one will be going to the 5-volt power supply, which will be one of these leads here. We'll have to read that after we put that on there. And then our AC is we're gonna solder 2 leads onto here, and then they'll go into the low side of the bank of the transformer back here, and then the other 2 legs of the transformer will go to the fan. And what we're going to do now is we're just going to leave that there, and we're going to start prepping out the side panel where this fan is going to be mounting, and on the other side of that panel we'll have the exit. So we're going to get those 2, we're going to do all the cutting so that we have all the hardware insertable, and then we'll go ahead and we'll wire it up, and we'll resolder our resistors in place. Okay, our machine is set up and we're in bypass mode, so we've got our plasma torch ready to go. We don't have to have that on, we can actually use it here. I've traced the hole that we want to cut out, and I've scribed it so I'm in there pretty good to where I can see it. And then we'll have 4 holes that we'll drill out there, and then our vent is over here on this side, so it's just gonna be flip it, and we'll be ready to go. Okay, doesn't matter which side we cut out first. And I think I'm gonna go right onto this metal here, so I'm not interfered with any paint on the box. And then I can reach right in here and see it with no problem. There we go. Okay, we've cut, dressed, grind, sanded our openings where they're pretty round, and I think they're going to be doable. We're going to line this up here, and we're just kind of taking a look in here, and that's perfect right near that edge. Okay, I can feel this area right in here, which feels pretty good. Alright, 4 mounting holes here and 4 mounting holes on the other side. And this is going to get a grate like this, and the other side will get the metal one. So nothing gets pushed in or makes contact with the capacitor lines running off of there. We covered our innards once more. We're going to be taking our ceramic disc with our DeWalt there, and we're going to slice it here and slice it here, because this actually comes in right next to this backing faceplate here on the back side, so that I have enough room so it'll make it between the capacitor here and sit right in that position right there. Alright, so it is tight, but it's going to make it, and we figured it all out before we bought the fan. We've already got the grill in the back, and we ground out 2 of the areas of the flange because we want it to be right there at the edge, and that looked good. but this is gonna probably throw just a little bit more than we want, and okay, and I'm gonna go ahead and slice it in here this way first. And then I'll just go ahead and go right down here. Okay, I think that's going to be plenty. We're just going to square that off a little bit with our disc sander, and we should be okay. Okay, we've got the grill in on that side. We have the fan. We didn't put the cover on here yet, although we could snap it on there because we're all done buttoning that up. There we go. Okay, and this might be a little tricky getting this in here. Now, of course, when this comes down to this point right here, we'd be plugging on the fan lead there, and then it'll go right in there and slides right into position. I like that. Okay, all three of our openings that we had to create and get ready here lets us finish up all the hardware or the cutting that we have to do. Now we can get in to the electrical. All right, and I can put that button back on here. All right, and all right, we'll go ahead and set that, get that on there. We don't need it, it's not in the way of assembling our LED. Cool. Okay, I've got the meter sitting out here, and we got one white lead here that's going to go up to the positive side of the capacitor, and then one leg of this black will go to the negative side, but it also has got to tie into the ground for the meter, and then the red wire will go to the other wire on here, which will be the hot leg. We need to find out which one is hot. Now, we don't need to throw away that, but we cut off the plug already and we stripped the ends here, so we're pretty well all set. We just need to know which one is definitely which one is going to be 5 volts and the other one going to be ground. So we go ahead and have our plug set up here, and we'll go ahead and we'll throw my meter set on DC there and connect each of those ends there. We'll plug this unit in, and we're reading -5, so all we need to do is switch these around right here to verify that we had them backwards, and we have a +5. And then we look at the hot lead versus the black one, and I mean the okay, and the positive has got the series of lines going down through it. Okay, so I'll know that the hot lead has got the stripes on it. Okay, and that's all we needed to know, because we're gonna be soldering 2 leads on here to catch the AC power from this side of the bus bar on this transformer. Because we've already read that out, we know that that's where we could pick that up from. Okay, shut off our meter. Alright, now let's go ahead and we're going to set up and we're going to solder our 2 leads on here, and we chose to match the color that was coming into the color is red and brown basically. So we got red and it's sort of red and purple, red and brown, somewhere in that neck of the woods there. So we're just going to go ahead and we're going to strip this off here and like that. All right, and they're two separate leads, so we'll be able to put string tubing over that. And now we'll just go ahead and set this up in here, and we're going to twist this around. You should notice it right away when the lights don't come on. Just saying. All right, we got our wires all crimped. Everything's all set ready here. The power supply, I've got a sticky tab back here. The power leads are over here, and we're going to bring these up and tie them into this bus bar here on this side of the bus bar. The power for the fan is on the other side, and that lead will be right here, and that can just tuck right in here, and as the fan goes down, that lead will stay right in there, nice and comfortable. This is coming over here, so we got to tag the ground side and the positive side of the capacitors. So we're just going to pick an area in here. Kind of looks good to us, and I think that looks good there, and oh, that area right there looks good for the positive side. All right, now let's go ahead and drill and tap those. Oh, you're right. Okay, you're not going to be crazy enough to drill in there. So we take a piece of aluminum that we already had planned on putting in here, and that way we will not drill into the capacitors. Alright, our hole's through without going into the capacitor there. We're going to worry about the shavings here in a minute as soon as we get done with this one here. And there we go. Alright, our two holes. And now we're going to tap them out. We can control our tap, I believe, without having to go in there. Okay. And that's why I kind of picked between so that the tap could go down a little bit without actually coming down on top of that. And all I need to do is get a thread or two past that. We have the screws that are going to go in here and the fittings and that. All right. I'm just doing this dry. I don't think I need to get in some tapping fluid. We're not doing a large quantity. And I'm going to sit down here so that my eyeball can concentrate on coming through. And you can see the chip being pushed right down in front of there. Okay. We have safely drilled that out. Alright, now let's go for this one here. We probably could have ran our shop back while we were drilling, but okay. Now we're going to get our air nozzle and we're going to blow this out this way here. Okay, the last electrical part or electronics that we're going to be doing on this thing is we're going to pull the board out of here and we're going to replace that resistor. We've already pulled the resistor out, cleaned the solder and put it back in, and we've already tested this thing and we know it works fine, but we're going to replace it with a larger resistor. And we're going to let it stick out from the board a little bit. Okay, so that resistor is going to be that one. We're going to be pulling that out of there. We may drill 2 holes right here and we might mount it here. We're going to be mounting it out a little bit farther so that the wind current will come by it from the fan and help keep it cooler. Alright, so this card just pulls out of here. And there's the back. You can see the heat mark right there. The new solder joints there. We'll take it on over to the bench. Alright, cool. Alright, let's go find us a couple pieces of shrink tubing. Alright, we got our little board in here. And you can see how old-fashioned this is, and that was the way they did it back in the day, is hand trace and draw out the path for the resistors. And you can see here, this is the toasted one here. Alright, now this part of the board here I've scraped down a little bit, and we want to double check that because we're going to be putting on this resistor, and we want to try to get it up in the air or get it over here off to the side and do a jumper. It's kind of, we have a couple different ways to go about that, and we'll use the orange for the jumper, right? Orange jumper. All right, the very first thing, and I've already soldered, I've removed this resistor to go ahead and test it off of the board, clean it, prep it, put it back in and make sure the solder joints are fine, and it does operate, it does work. But we want to go ahead and replace it all together, and I think we're gonna mount this new resistor, and we may mount it on the board up in this area right here, or equal to it here. I'm just kind of looking at where we need to put it to clear our traces. The first thing we're going to do is we're going to remove that resistor from that path there, because we'll need to have those holes open and clean to the trace. Alright, prep our solder sucker. We're going to be doing some sucking on our solder there. And our iron is already heated. Wipe it on the paper towel just to go ahead and clean the end. Alright, and here we go. Let me see, I'm going to set something underneath this. I found before, you know, this rocks like this, but if I get something under each side there. Okay, I found a couple pieces of key stock. Should be high enough to go ahead and keep that from, there we go. Okay, now we can have some downward pressure on it, and here we go. It almost lifted it off of there. Alright, let's do the other one here. Okay, we're ready to go. Thought we had a solder sucker meltdown. All right, here we go. All right. That came out pretty clean. A little bit more. Okay, let's see. How we did there. That side came right loose. This side over here, a little bit more. There it goes. There we go. Okay. Let me see if I can zoom in on that area. Okay, I scraped all the burnt area down. Now what I wanted to do is take and hold my scale here. And the concern is how brittle. I mean, that was worn down there, but right out here is pretty, it is pretty firm still. John was kind of advising me to pick 2 new holes there. Okay, I'm not gonna question John's judgment there because he hasn't steered me wrong yet, and my usual practice too is if it's iffy, make it so it's not iffy. So anyway, when I took the drill, and the reason why I took this drill is I measured the thickness or the diameter of the wire coming out each side of the resistor, and we're right about 40 thousandths or so. I picked a 43 thousandths drill. It was just close to it. We'll go ahead and strip the jumper wire here, and that's measuring like 35, but if we were a pretty good twist here, what would we have? I'd say 40. We're close to 40. Here's a good test. Let's see. Oh, we just did that too fast. Okay. Nice comfortable wire. Let's actually see if it'll go through this hole here. No, it won't. Okay, let's just see if we can do that without molesting it this time. Okay. Okay, we're not going to be able to put that wire through there. Either we got to open that up. Alright, let's see about getting just a tiny bit larger drill bit and see if we can get that wire to work for us. Okay, we just got done reaming it out with a 52 thousandths drill bit, and okay, we can get that wire to fit in there comfortably and make. Okay, no problem. All right, and we still got good landing there. So we can still create our solder glob on there. We should be doing good. All right, and we haven't molested the traces too bad there. I think we'll be able to handle that. Okay. Okay, I just want to grab this here so that I don't interfere with that wire going that way. And I don't know how easy this is to bend. Oh, it's not bad. Okay. And I'm just going to keep it kind of square, or 90 to that. Okay, and put that in that direction there. Okay, I like that. And we got them parallel. Now, if we were to put this back into that, we would have had to bend it back in and then in there, and then we could have dropped that right in those openings. All right. This is going to be, we can hold this up to the light so we know where we're going to be here. We still may actually need to bring it back in. We'll just bring it back in the width of the stats there. Okay. All right, I like that. Let's match that on the other side. We'll leave that. I mean, I'm not going to be... like that. All right, it's not the prettiest thing, but I think that will work. It'll get it up in the air a little bit. That's kind of what we wanted. And I got some high heat silicone, I should say. All right. So what I need to do now is go ahead and drill us. Spazzing out here. Okay, I just need to pick a location right here to drill a hole, and I'm going to drill a hole there, and I marked it on that side, so let's mark it on this side here. Okay. All right, I'm going to go ahead and go into the mill so that I can hold this and drill us 2 holes through there for that to fit. Okay, we had one that had like a burr or something on the end here. All right, let's check this out. Let's see, we're going to go in this way here. All right, cool. All right, and we can probably tweak that just a little bit so we can get it down just a little bit more. Let me see what I can do here. Okay, I think I'm gonna like that, and I'll be able to put a glob of silicone underneath there just so that it's shock resistant. I have some really high heat, high temperature gray. I just used some of this on my side of my case on my Porsche there. I had an O-ring that was giving me an issue, and I don't want to change it out right now. So, all right. So now I can trim these off exactly where they're going to be, and I can put a little glob of solder on there to hold them, and then we're going to make up the jumper wires and attach it to that wire and the solder. Okay, I've got these ends down, straight down into the old trace, and then I curved these around so that they were comfortable around everything. And I actually left a little tail here and I formed it right around so that when I solder that, it's going to be a nice glob and a contact there. I think we're going to have really good success here on mounting this. All right, and the other side looks just like that. These are up a little bit higher, but I don't want to snip them off until I know that I'm bonded in there, and I might actually even just wick a little solder on this side here so that it actually is creating a bond so that it's not going to move anywhere. All right, I think we're going to get the soldering iron going and we'll take care of that. Okay, let's start off with this, and I think I might actually, am I going to need to? I'm going to stick that up there. Well, no, I want that resistor there to be supporting the load because I'm pushing on that. Too many things in one hand here. Okay, there, okay, that's good. All right, I like that. And I'm going to steady my finger on this side here. Okay, I think I'll be able to. I like that. Okay, let's go for this one. Nice. Okay. I'm going to come in here next to this wire and hit that trace right there. Okay, I got to put that over there now. I'm pressing down just a little bit different here. Same problem with my TIG wire, right? Okay. Get this nice and warm here first. Nice. Okay, I want to approach this from this side here, but I want the visual that I have right here, so I'm going to rotate this board around here. Okay. Now this is the one that was kind of questionable on the trace. I want to really make sure I got a good amount going down on this piece here. Okay. I wicked solder all the way down through that wire on this side, each side. I think I did a good job there. Yeah, a little gob of silicone underneath there. Do I really need to put anything there or not? I already had solder come down through there. I'm joining the traces, but normally the resistor would be on the side here. None of these other resistors got solder on this side. I think I'm gonna let that go just like that. I'm not gonna. Sometimes more is not better. All right, I think this is ready to plug in and test. Okay, I just screwed the card in there, and I just need to power this on, just making sure that no sparks are boom, boom, boom. Okay, we got 116, 117. Just increase it to 126. Okay, I'm going to shut this off. All right, no booms. I'm going to turn this all the way down now. Turn it back on. Okay, and we're at 50 amps or 50 voltage. And it's still slightly dropping because where the dial is down to 30 or so, and it's slowly dropping. Okay, all right, we can unplug that and we can let that bleed off, and we'll be able to squirt just a little bit of silicone rubber underneath that resistor there. Awesome. All right, we're coming down to one last thing we want to do to this before we button up the cover and put it to its final testing, and then get it set up so that we can use it. The rivet nuts, I put 3 in on the other side there. We got 1 here, 1 here, 1 here, and we have 4 on the top yet to put in. All right, now we're going to go ahead and we're going to do these bottom ones. There's nothing really behind here with the drill depth. That's no problem, but right here I have this power coming in here and a wire here, so I'm going to take a piece of thick gauge metal here, and I'm going to slide it all the way down into that corner, and then I'm just putting a little vice grip here, and I physically eyeball and make sure that I am seeing that metal there. That's going to give a little bit of a break so that my bit's not going to go jamming into some wires there. All right. The drill bit size I'm using is just 1,000 or so over this diameter of the draw rivet. You want to use the recommended sizes, just like pop rivets. All right, and all we're going to do is we're just going to come in here and open that up, making sure that we're going all the way through. Looks like we made a round hole. All right, and slide our piece out. We're just going to check our fit, and it's good. All right, this is similar to a rivet gun. It has to draw, instead of drawing on the center pin on a pop rivet, this actually creates a threaded pin that pulls it and then crinkles that knurled area. You can buy those knurled or unknurled, and I chose to use the knurled ones. All right, and you can you can adjust your stroke on here, which I didn't do that. Okay. Alright, squeeze that in. Now we unscrew it. And we're all set. I could adjust that stroke so I'm not so open-handled is what I was trying to say. And there's our screw. Alright, we're going to go ahead and knock out the other ones here. See how I pull that in? That's a hazard if you got something in behind you. Okay. I'm going to adjust this a little bit so I can get a little bit of a start of a closed handle. Okay, here we go. Makes it a little easier if you can squeeze it. Real simple to put in. Alright, now here again we have this little breaker right here. And we're just going to put this underneath here like this. We put it over here so we can have a little bit of a spring action on it. And we're going to vacuum and blow this thing all out of, you know, all the chips and everything else out of there. Just as we did when we drilled and tapped the holes in there. And we cut out the gauge. All right. Here we go. And we'll go ahead. This is quite a ways down, but I don't really want to take any chances. There we go. Let's see, we got 3 more. Okay. I think we're done with that. That's pretty open over there on that side. Okay, danger, 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 Will. All right. Right on through that that card, huh? Yeah, let you push on it a little bit there and make sure that you cut out the little push out on the other side. You get when drilling. A little bit of chips in there still. Okay, and we saved that one for last. All right, ready to put the lid on. We're going to give it another good look around in here. We're going to get a flashlight and make sure that we have everything blown and cleaned out of this piece here before we button it up. just before we button this up here, we're going to go ahead and run through the original test we did just to verify that we had a good component before we started, knowing that we had something good to work with. And that was doing a test for shorts and a test for opens. And then we went into resistor checking, and that's the two resistors that we replaced. They still were in the limits or the requirements for those resistors, and we changed those out just because they've had a bit of life already. All right, to test for shorts, we started the power's off and discharged all banks, and just verifying here that we're down to 0, 0, 0, and 0. These two bars here are the negative side of the capacitors, and these are the three. This one is always live. As soon as you turn it on, that one bank will always be charged, and then you have 3 additional banks that come into play. So when I say that we're going to be testing the 3 banks, it's one is always live, and we'll verify that that one actually comes up to what we have the set here. Right now, with the dials all the way down to 30 volts, and we'll turn it on, and we got 42.2 actual volts, and let's see how close our meter is here. 42.42. all right, now testing for shorts, we should have 0 volts or real close to it. We do there, we do there, and we do there. All right, so we don't have any shorts. A full charge would mean the big diodes are shorted out. These are the 3 diodes back here. Okay, now we're going to test for opens, and we're not going to turn it back off. It just means turn on with the full all banks on. Okay, so all banks are on, so we should have 42.9 on the other 3 here now as well. 42.8, 42.9, 42.9. all right, now if one of those was open, then one of the smaller diodes right back here coming off by the transformer, those would have been bad. Okay, so all signs are good right now, and if we shut it off, it should bleed off to 0, and that's where that large resistor back here and the other small one on the board come into play, and that they are to bleed off the power stored. And we're at 24, 23, this drop at 22, 21, 20. All right, and 18. They're all dropping. 17, 16. Okay, those are bleeding off, so that's telling me that my resistors are good. All right, we're going to continue. We're going to unplug this, and we're going to let it die down to 0, and then after that, we'll go ahead and we'll put the cover on, and then I think we're ready to plug in our leads and our gun, and I think we're going to be ready to go. Okay, power's all bled off. Let's go ahead and set that up there. Now the front and the fan is not really the tricky part. The tricky part is the back part here. Okay, I'm going to let it sit there for a minute and plug in the fan here. Okay, and then that wire just kind of goes down with that fan there. All right, now we're going to bring it forward here. And then we got to pull this out. There we go. This screw and this screw here are real close to that vertical, and I have to give it a little clearance and then go into the little cutout or relief I made for it. All right, screwdriver and my screws. And now we don't have to deal with any sheet metal screws or wood style screws. And we know that when we lift the those capacitors are heavy, and that's why they got some serious handles on these. This is back when they made pretty good pieces of equipment here. My stand here's got a bit of a rock in the position it's at right now. Might have a seashell from the driveway underneath it or something. They get tracked in here through the front door sometimes. All right, I think we're ready to go get our leads, plug them in. Let's test this bad boy out. Okay, we plugged in our ground lead. We've moved our machine over so that we have direct plug into a nice wall outlet, and we're not running through any extension cords. The next rule that's really important with working with DC stud welders with capacitors is not to coil up your leads. So you want your leads stretched out on the floor so they're not coiled up, because it will interfere with the current you need to have at the stud itself. Okay, and now bring this machine over to the edge here so I can get my hand all the way around. I might want to go ahead and put a little lubrication on those fittings there. All right. Now we're just going to stretch this one out here, just so it's not coiled. Okay. So we got our ground and our gun. Now we're going to set up a work area right here. And let's see what we can come up with. I think the stage is set now. Nice working platform here. We're going to put the ground on, and I'm using the chair, but I always like to make sure that I'm putting the clamp side that has the ground connected to it onto the metal that I'm going to be using or welding on, as a general rule. Also, sometimes when you have a loose connection or whatever and you might get a little arc, you want to make sure that that is on the side of the part you don't want damaged, in case that happens. All right. Back when I picked up this machine, I picked up 1/4 inch and I think 1024 or 1032 size studs, so that I had something to practice with, and it was a common size that I felt that I would be using. These studs they have a tiny flange on them, and they have a tiny little tit right there. When it comes down, it actually sits just above the material right there, and I think that has all to do with the contact. Before these came in, I took and machined a few bolts down to represent what this is drawn out, and on the internet I googled it and I found out that shape. I did some practicing with this thing before I decided to take it apart and modify it and so on. So the gun is already set up with that, and this is a collet on here, and then this has a somewhat of a spring pack on here until these 3 contacts touch the surface right there, and then you squeeze the trigger and fire. All right, that's the mechanical end of it. And the setting side of it, we'll go ahead and we'll flip this on. Nice, huh? Fan's working. Got a nice airflow through there. All right, we got 42 there. And I think I grabbed this out of my notes there because John helped me with this project as well, and you guys know that. And he printed off this stud Welding settings, and I think it's the closest that he found that matched the capacitor range and everything else in this machine here. This machine is 1984 or so, and there's no direct manual for it or anything else that I found online. But if anybody does have a Nova stud fuser and you do have the original manual, I definitely would appreciate that. I don't know if Stan actually has the original manual for it as well, but anywhere online I haven't been able to find it. Anyway, coming down here, diameter quarter inch size, says bank 2, so we need to add the second bank, and that should set the capacitor level at 84,000 and 128 on the volts. So we'll go ahead and we'll move the dial up here to 128. Actually, we're gonna pay attention to the digital here now. I went just a little past it. 131. We're at 130, and actually it's on the 120 dial. It dropped down 128 right now. The capacitors are doing their job. You can't just like turn that down. It's not going to follow you all the way down, but it will settle out with the extra that's put in there. So, and that's what this is proving to be. And it is touchy, right? I mean, just a minute amount. It's coming back up to 127. All right, that's close enough for a test. we might be 10, 20. We might be a capacitor off. We don't know. All right. So here we go. And of course, this is not like regular arc, and I'm not actually going to be staring in at the contact there, although you can stare at it if you want to. And where am I going to put it? I'm just going to put it right here, and 3 points level. Squeeze the trigger. All right. You can hear that recharge. Nice explosion all the way around. I'll give you a quick picture of what we got here close up. All right. And I'm going to go get a C-clamp. And I think we have couple oversized nuts. We got a washer, and we got a nut. We're going to do a pull test on this. Stan Zankowski, when we were talking back when I purchased this, actually Stan was part of the reason why I have this machine as well. We did some pull tests on some of my other studs, and I had good success. So this is a very good way to actually test, and if you can part off the stud before you pull it off of the plate there, that's the ultimate test right there. All right, I'm going to go ahead and grab my wrench and a clamp. Okay, that's just so I have a little bit of force here. Okay, I did pull it slightly from the bottom of the weld joint there. And let me get you a close-up picture of that. Okay, our puller kit, put that over there, and let's grab another stud here. All right, that was a good starting point there. Let's go ahead and we're just going to increase the voltage a little bit. I say about 140, 142. I don't think it was too far off. I mean, that was taken quite a bit. All right. That spark looked a lot better, and it's pretty uniform all the way around. The other side had a little bit more spray off of one side here. Okay, we're set up. We don't have to wait for it to cool down. Yeah, I don't think I need my gloves to. There we go, okay? Excellent. Okay, yeah, we put on a couple more, and we were just checking out some slow motion shots, and we picked up the nut. This is the nut off the other one. I just unscrewed it, so we'll be able to test. I mean, we got one to separate the threads before it let go, and you gotta make several tests, right, before you. Okay, there's another one that broke. Okay, and we snapped off there. So we have got a good setting for 1/4 inch stainless steel studs on stainless steel. All right, cool. I feel good about my investment and how it's doing. Really glad I went through the effort to do a few of the things there. Hope you enjoyed the venture with this project. Until next time, get her done.